Hey folks, how's it going? This is Mr. Murray coming to you with a Do Now for Course 2 Honors for Friday, April 17th, 2020. Okay? This is going to be our last Do Now before we go off to break. So I thought I'd preview this kind of concept about finding this little sector by using what we already know. And so all we have to do is we have to remember that a triangle is equal to the base times the height over 2. And then we also have to remember how to calculate the area of a sector, given an internal angle. Okay, so using this formula here, what we need to do is find the area of the segment to the nearest hundredth. We'll say that pi is equal to, I'm going to want pi to be, let's do 3.142. Though 3.14 would probably be fine. Given this angle measure is 60. Sometimes we actually see 60 written out here. Either way, they mean the same thing. And given a radius of 20, using this formula, find the area of the segment. Okay, so what we're going to do, and remember, think about what kind of triangle this is. This is a 60-degree angle. Think about what would happen if I drew a line right here. Alright, so take a second, pause the video. Okay, and then when you're ready, unpause, and I'll show you how to solve. Okay, so basically, let's get started with 60 degrees. So first I'm going to calculate the whole entire sector. I'm going to start with this piece. So remember, we're going to start by taking the angle measure, and we're going to divide by 360. Because 360 is the total degrees in a circle, and that's equal to 1/6. So because 60 is a sixth of 360, the area of the sector is a sixth of the total area. Okay, and to find the total area, we're going to take 20. We're going to square it, because 20 is the radius, and we're going to multiply by pi. And that gives me 400 pi meters squared. I'm not going to actually fill in what it is, because first I'm going to actually do the calculations, then I'll probably do the subtraction, and then I will do the segment rounding last. Okay, so now I'm going to come over here. So basically, what I've done for actually though I'm not done though because I actually do need to divide this by 6. Sorry, I don't want to get ahead of myself here. So 400 pi is the whole area, and I divide by 6 to get the area of just the segment, because the segment is a sixth of the total area. Remember, this is the total area. Okay? And when I do that, I can simplify. That's 200 over 3 pi. Okay? So that is the area of the segment, the whole thing. But I don't want that, right? I want to take away this triangle. So if we take a closer look at this triangle, we know this is 60. This is actually, we know this to be an equilateral triangle. The way I know it is because since this is a circle, this leg and this leg are radii of the same circle. And all radii of a circle are equal to each other. So therefore, these two sides are equal. So therefore, these two angles are equal. But since these angles have to be the same, and all three angles have to add up to 180, we can conclude each of these is 60. And so with an equilateral triangle, if I draw this line down the center, what I get is, cutting this in half, I get a 30, 60, 90 triangle. So these cut in half and become 10. And by the rules of 30, 60, 90, this becomes 10 root 3. So the area of the triangle is base times height over 2. Right? That's the area, so that's 100 root 3 over 2, which is 50 root 3. So what I want to do is, I want to take this, and I want to subtract 50 root 3. Okay, at this point, I'm going to make the substitution, so I'm going to do 200 times 3.142 divided by 3 minus 50 times the square root of 3. You can do this all on your calculator. Here's what it looks like when I put it in my calculator. I'll show you. This is what my window looks like. 200 asterisk 3.142 slash 3 minus 50. And then for me, it looks like square root, and then it puts a parenthesis in there, 3. Okay, and it knows how to do PEMDAS, right? Because this is first you'd be multiplying by pi, you'd be dividing by 3, and then etc., etc. So when I do that, I get approximately 122 rather, 0.86 meters squared. If you use 3.14 instead of 3.142 on this one, you get 122.73. So you actually do get a different answer. And so if this was done on my HRW, you'd have to take that into consideration. I'm assuming you'd use 3.14. But that's essentially the idea. This is what we'd call a dissection, right? You take the total amount, which we know is 200 pi over 3, and I subtract out this piece, this red, so that all I'm left with is the remaining amount here. Okay? So hopefully you're able to get this right. If not, I'd suggest, go back and take a look and make sure you understand how I did it. This is meant to be a challenge problem to kind of test your knowledge on sector area. This part is extremely important, and if you're still stuck on this, I recommend you go back and take a look at my video from the other day, the Hangout on Wednesday, and kind of the problems we've been doing online. But have a wonderful break. I'm looking forward to seeing everyone back on the 27th. Don't forget about your math, and remember, you can do it. Have a wonderful time.